This is 1992 AP Physics B question. Now the sections are covered in AP Physics 2, geometric optics. So a thin double convex lens, a focal length is given 15 centimeters, is located at the origin of the x-axis as shown in the picture. An object of height 8 centimeters is placed 45 centimeters to the left of the lens. On the figure below, draw the ray diagram to show the formation of the image of the lens by the lens, and then clearly show principal rays. So again, to do the principal rays, we follow the rules of the rays, and those would be parallel to the axis through the focal point, and the focal point is 15, so here through the focal point, then through the center without bending or without refraction, so that one goes all the way through, so through the center, and then the next one is going to be through the focal length and then parallel to the axis. I have the third ray, and my image appears to be somewhere right here. For the next question, they ask you to calculate, but do not measure each of the following: the position of the image formed by the lens and the size of the image. If we use the lens equation, so we have 1 over the focal length equals to 1 over the distance to the image plus 1 over the distance to the object, we will have 1 over 15 for the focal length equals to 1 over 45 for the distance to the object plus 1 over the distance to the image. I'm going to times every equation by 45 to get rid of my number denominators. So the first fraction multiplied by 45 gives me 3. 45 times 1/15 is 3. 45 times 1 over 45 is 1. And then the last one, I have 45 over di. So from here, I see that di is going to be equal to 22.5 centimeters. So that is the distance to the image. So this is 15, this is 30, this is 15 on my graph, and this is 30. So somewhere between 15 and 30, my image appears at 22.5 centimeters. To calculate the size of the image, I have to find the magnification, and that one has a formula negative di over do. So I have negative 22.5 over 45, and the magnification is going to be equal to negative 1/2. So the negative sign again stands for the image being inverted. Also, inverted image is formed where the ray meet in real life. So that means they intersect at that point, the real rays, and the image is real and inverted in 1/2 of the size of the original image. So the height of the image is the magnification times the height of an object, and since the object is given to be 8 centimeters height, so this one is 4 centimeters in height. For the next question, they say a concave mirror with a focal length of 15 centimeters is placed at point the distance of on the x-axis at 30 centimeters, and then on the figure below indicate the position of the image formed by the lens and draw a ray diagram to show the formation of the image by the mirror. Clearly show principal rays. So here I have the image formed by the first lens. Now I have to do the rays for the mirror. And the mirror also has the focal length, so this length is 15 centimeters, and it is 30 centimeters away from the lens. For the ray diagrams, I have to follow the same rules. So at first it is parallel to the axis, and then it has to go through the focal length, and the focal length for this shape, let me maybe show it this way. So I have this shape, and the focal length for this shape would be on the same size where the image is right now. So the focal length would be this way, so the ray would be reflected that way. The ray that goes through the center of the curvature of the mirror would be, so here is the center of the curvature, let me put the red dot right there. So the ray that goes through the center of the curvature of the mirror does not bend or refract, so it would go this way, reflect back in the same direction, so it would go along this line. And then if I make continuation of those rays, because if there was an observer at each point, let's say an eye over here looking at that ray coming in and an eye over here looking at that ray coming in, then both eyes would think that the object is actually located at this position. And this image would be also, the previous one's real, this one would be virtual because the rays do not meet at this point. They appear to come from that point for the observer. And if you went on the other side of the mirror, you would see nothing on the other side because the rays never meet on the other side. And in this case also the image is, it's not inverted from the original image. So the original image you had was already inverted from the original object. So the first one was real, but then the second one is virtual. There's one more question that I accidentally missed. It's part C. Describe for the previous question, for that question above. So what they ask you in C is to describe briefly what would happen if the image formed by the lens, if the top half of the lens were blocked so that no light could pass through. When this part is dimmed and no light can pass through the top of the lens, then this ray would not get through. But the other rays, this one and this ray, would still get through. And because those rays get through and the top rays don't get through, then the image would be not as bright as if the top of the lens was open for the light to pass through. So not all of the light will pass through, but some of the light will pass through and make an image not as bright. And that is all I have for this question of 1992 AP Physics B, now covered, sections covered in AP Physics 2. Thank you for watching, and I will see you in the next video.